Thanks a lot, and thanks a lot for coming to this talk, Microservices Journey from a startup perspective. So when you usually hear and read about success stories about microservices, you usually hear about large industry players having introduced microservices successfully, like Netflix, Amazon, eBay, and just to name a few. And if you look at those success stories, you might end up saying, oh, that's what worked there, we can apply to us as well, let's just copy that. But the problem is that you miss one point, is that every journey to microservices is different in every organization. One of the reasons is that the circumstances for every organization are different. So the circumstances that are affecting your journey. So one of the circumstances could, on the other side, be your team structure and skill set and size, which has a direct impact on your microservices journey. So your transformation process itself, it's not running in isolation. So, for example, if you're a small team with very little DevOps practices in place, it has a huge impact on your transformation process velocity. And if you also take into consideration that you still have to run a legacy system, you still have to maintain it, you still have to take care of it. And this one is also taking care of your legacy system, reduces the time that is available for your transformation process. And also what's impacting your journey is also your runtime environment. Are you running on-prem or are you running on cloud native? So can you rely on managed services, for example, an API gateway? Or do you have to set up everything from scratch and maintain and monitor everything? And also, what's very important is your strategy. Are you forced to implement new features in a very short period of time? And if you are very struggled with this one, but if you have a very short period of time, you might struggle with where to implement the new service. Shall I put it as a new service, or shall I add it to the monolith and feeding the monolith again instead of shrinking it? So to give you a little background, I am Susanne Kaiser. I used to be the CTO of Just Software. That's a startup in Hamburg. And at Just Software, we are developing Just Social. That's a digital workplace, providing collaboration apps for your teams to communicate and collaborate within teams in your organization. And a long time ago, when we started in 2010, everything was a monolith in every aspect. So we had one team working on one collaboration product and implemented as one code base based on one technology stack. So after a time, everything was growing. So our team got bigger, we added more and more features, our user increased, and the code base got bigger and bigger. That's supposed to be fantastic, but we had one problem, that everything was feeling kind of clunky because everything was tied together. So on the one side is that the fact is that we added more and more features. The thing is that we had to release those changes quickly. And the problem was that because our team was growing bigger and bigger, the decisions and discussions and meetings took longer than before. And which we also didn't have really well-defined responsibilities. For example, when a bug arises, who's taking care of it with one team? So the processes were slowing down and our productivity suffered. And due to the fact that we were adding more and more features, the usability became more and more complex. The usability and user experience suffered through continuous feature amendments. And instead of solving our users' problems very easily, we were increasingly confusing them. And due to the fact of the nature of a monolith, it was not very easy for us to release changes quickly, because whenever you would like to add something, you have to rebuild and redeploy the entire ship, the entire mothership, even though if you have just only one single line of code that you have changed. So, and this resulted in high-risk deployments, and which happened then less frequently. So your new releases, your new changes released new features released very slowly. So more than 2 years ago, our product vision changed, and we were focusing on usability and user experience improvements. So we divided our one collaboration app into separate collaboration apps, each of them is taking care of a specific use case, taking care of one problem and solving this problem very well. So we had a collaboration app for exchanging documents, for communicating in real time, for managing your tasks, and also distributing and sharing corporate news and content pages throughout your organization. And right after this, or probably mostly in the meantime, we also split our one team in multiple smaller teams and assigned to each of those teams a specific set of collaboration app to enable those teams to work at well-defined responsibilities and to enable them to work at different parts of the software independently with minimal impact across the teams. And so as a reasonable next step is also to reflect this autonomy and also flexibility also in our software architecture, and by introducing microservices to gain also autonomy in our software architecture as well. So the motivation for us from microservices was to enable autonomous teams working at different parts of the software independently at their own speed, at their own pace, with minimal impact across other teams, and develop and deploy the collaboration apps independently and also scale them more effectively, so that in the end we can release changes quickly. So when you have decided to start this journey to microservices, the first thing is that you have to identify good candidates for microservices. And to model good candidates, one of the key concepts to model good services is to follow some key principles. And the key principles for modeling good services follow the high cohesion within a service and loose coupling between those services. And usually in the domain-driven design, high cohesion within a service is usually reflected by related behavior that shall stay consistent. And so bounded context itself, it's a semantic boundary around a domain model where a domain model lives in. And they describe services that are responsible for a well-defined business function. So for us, in our case, we identified our collaboration app as the perfect candidates for high-level coarse-grained bounded context that we can use as our starting point for our decomposition journey, and then starting from this high level to finer-grained ones later on. So we started with Just Drive. That's the collaboration app for taking care of sharing documents within your teams. And each document itself is created by an author. And the author data itself is stemming from the profile data. And the profile data is stemming from another bounded context, which still resides in the monolith. So we started extracting the bounded context of Just Drive of our document collaboration app as a coexisting service from scratch. And we modeled the bounded context composed of its domain model and taking care of reflecting the business logic, but also the application service orchestrating use cases and managed transactions, and also the input and output adapted of your bounded context. For example, REST APIs and your persistent management on the other side. And this new service then owns the document state exclusively. So that's the only one that can both read it on the one side, but also modify it. And as mentioned before, we had this author data that is related to a document, which we would like to also reflect in our new service as well. But the author data is stemming from the profile bounded context, which resides still in the monolith. And the monolith itself, it owns the profile states exclusively on the monolith side. So, and to avoid, when we are displaying a document, to avoid to request the profile data or the author relevant data every time when we display a document, we implemented an event-driven approach. So the thing is that we kept a local copy of the author-relevant data in our service itself, and to keep this local copy in sync, we asked the monolith was notifying us about profile update events. So whenever a profile has been updated, the monolith was publishing the profile updated event to a message broker, which our new service subscribed to. And when the event got received, got consumed, it was updating its local copy accordingly. So what I have to say at this stage is that the coexisting, going back a little, so the coexisting service that we established was not an exact equivalent of the current one. Instead, we also weaved into this transformation process a user interface. We added new features, and we also did significant adjustments to the data structure itself. And that was causing us troubles. So usually the coexisting service from scratch is in general a good approach, a good decomposition approach, especially if you would like to move away from something, if you would like to move away from your current business logic, if you would like to move away from your tech stack, for example. But what in our case it was, the problem is that we put a lot of new things to this transformation process as well. So we did too many steps at once, especially in the beginning. It was not optimal to start with, because in the beginning, if you are starting with no experience in that microservices world, in this microservices world, the one thing that you have to focus on, that you get early results and get fast results, especially in the beginning, because you have to gain experience in that field very early. So, and with this approach, a coexisting service from scratch and adding on top a lot of other challenges as well was not optimal for us. So, with the next bounded context, that was a chat app, we followed a different approach. We wanted to get earlier results. So we followed the decomposition approach of decomposing it incrementally from top to down. So we started to extract the user interface as a separate web app and provided a REST API on the monolith that the new web app could address. And this allowed us to develop the user interface independently and iterate on the user interface rapidly. So the next step was that we shifted the business logic to the new service. And untangling business logic is causing significant code changes. And in some cases, so it depends on the dependencies. We also had to provide an API for the monolith that the monolith can then use our extracted business logic as well. At this point, we still had the same data storage, and we were addressing the same data storage of the monolith at this point. And to achieve an decoupled, independent service, we had to move this data storage as well. So that was the last step of our incremental top-down decomposition approach. So, and when we moved the data storage to the new service, we had to reflect the circumstance that also in this case, each chat discussion was also created by chat participants. The chat was created both through this chat participants, and this chat participant data was also stemming from the profile data, which still resides in the monolith itself. And we also implemented here the event-driven state transfer principle to keep a local copy at our new service and get updated whenever a profile has been updated on the monolith. So when you have multiple candidates for microservices, one of the challenges is to prioritize your next candidate. And what really would work better is if you have, as we did with decomposing our Drive app in the very first beginning, what really works well is if you keep this candidate very small in the very beginning. So if this has very little dependency, so if it's very easy to extract, because what you get out of it is that you get early results and you gain early experience with microservices in particular, but also with the decomposition process in general. And also your team gains confidence by getting early experience with microservices. And then you can also move on with the next focus on those services that generates the greatest benefit after extraction. So one of the benefit could be that if you have a service that changes very frequently, it's a good candidate to focus on next, because after extraction you have the possibility to deploy the changes very often, very quickly. Or you can also focus on those services that require different resource consumptions. For example, if you have a service that requires more memory than others, you can deploy it on instances with higher memory power. So for example, we had one service that was generating document previews, which they needed different resources in terms of CPU. So after the extraction, we could deploy those services on instances with more CPU power itself. And so with every service that we extracted, we got confronted with the question, or with most of the services that we extracted, we got confronted with the question how to handle cross-cutting concerns. In this specific case, how to handle authorization. And to give you a little context, our authorization model is very, very fine-grained down to object level. So for example, in Drive, you can control the authorization of a document by setting the authorization of its parent shared folder. But what increases the complexity of our authorization model is that it's inter-service dependent. So it also relies on the settings of authorization data that resides in a different service. So, and this was, for example, if you add documents to a content page and the access rights of these documents are controlled by the authorization settings of this content page, and the document itself is residing in a different service. So this was causing us a lot of headaches. And to handle authorization, and as a result was that we did not solve the cross-cutting concern of authorization from very early on. Instead, we postponed it. Okay, we find a solution later. But the consequences were very, very counterproductive, because since we have not really provided a distributed authorization handling, as one consequence was that we implemented the authorization, we added the service itself that we have identified to that area where authorization has already been solved, and that was the monolith. So we ended up feeding the monolith again, and that was, your goal is to shrink your monolith, and we was very counterproductive as a consequence. And the other side was that we were re-implementing the authorization per service level. And the thing is, usually at first glance, you would assume, or also our early assumption was that the authorization itself relates to the domain model. But due to the inter-service dependencies that I have described earlier, it's a cross-cutting concern. And the thing is that when we re-implemented it per service, we duplicated the logic itself, but also we were shifting data back and forth and had introduced the risk for collision. So that was also very counterproductive. So to make a long story short, we merged the authorization into a centralized service as a cross-cutting concern. But merging a decentralized approach into one is also very, very time-consuming. So and the thing is, to avoid feeding the monolith or to re-implement a cross-cutting concern with every new service that you introduce, handle those cross-cutting concerns very early. So if you would have had an earlier solution, we would not have run into these problems. So, and the next challenge when you introduce, especially when you introduce a centralized service, is avoid to introduce a distributed monolith. So, for example, when you make changes to one side and you need to change the other side at the same time and redeploy together, that's a strong indicator that you have introduced a distributed monolith. And so that, for example, when you add a new service or when you introduce a new service or when you make a change to a new service and your authorization service has to be updated at the same time, then you're combining both disadvantages of both worlds. Like you have a tight coupling system, but they are now communicating over the network. And one thing how to avoid a distributed monolith is to establish one stable common contract that the centralized authorization service owns, and that all other consuming services are or downstream services have to translate to, has to conform to. So whenever a service on the one side is requiring authorization-related actions, it translates it into this one common contract and can be handled on the authorization service without extra translation itself. And another prerequisite for this one is that this common contract is stable, so that you don't have to update all the services that are translating into this contract every time when you make a change or a breaking change to the authorization service. So the authorization service have to make clear that this has to follow the principles of a stable common contract, which does not change that much or that often. So, and when you introduce microservices, is that you have to take care of the service interaction. As in the previous example, I was given the event-driven interaction style. I was describing that one, where you have services that are not communicating directly with each other, but instead they are publishing events to a message broker or subscribing to events from this message broker in order to flip the flow control to the receiving end and to make this the services themselves autonomous and decoupled. And another interaction style is the request-driven approach, where one service calls another service directly over its API, and where the flow control of the communication is mostly controlled by the sender itself, but where services are more tied together. Or you can also combine those patterns in a hybrid model, where you combine the request-driven and event-driven model together. Another challenge when introducing microservices is the question how to manage shared data. And as I mentioned before in the interaction model, the hybrid model can be used as one solution, where your services are communicating over events, but only for notification purposes. So when one service needs additional data from another context, it does a direct call to a remote cross-context call directly to the source, with the downside that you are coupling both services together. So, but you might want to go for the simplicity instead of maintaining a data set locally, especially when this data set is growing. For example, when you go to the next model, the event-driven state transfer, where you keep a local copy of your data. And there you use the events not only for notification purposes, but also for data duplication for your state transfer itself. One of the downside of this one is that you have to maintain the data set locally, and this data set, this local copy itself, might grow very fast over the time. And another data-related aspect that you have to consider is the source of truth. So usually in a traditional event-driven system, you are usually listening to events and save your actions into a database, and you are emitting new events as well. So, and for your internal service itself, for your service itself, the internal source of truth is your database, but all your downstream services are, for them, the source of truth is the message broker itself, or the event store where it's stored. And the thing is that you have, in this one, the complexity of dual writes. You write to the database, but also to the message broker. And also another complexity is that the data model between the database itself and also the event format might diverge over time. So you have to consider or to be aware of divergence between those both worlds. So as an alternative, the alternative approach is to merge those both into one event store, and where events are considered as first-class citizens and are the primary source of your services. So in this case, the services are addressing the same source for the data, a single source of truth. And in this context, Kafka comes into play. So Kafka is a distributed, scalable, fault-tolerant commit log service, which is originally developed by LinkedIn, and it combines the capabilities of a messaging system, a storage system, and also a streaming platform. So in our case, we have introduced Kafka very early on, but mainly in the very beginning for notification and data duplication. That were the main cases that we have used Kafka for. So, but lately we have introduced Kafka streams as well, and trying to get some experience with Kafka streams as well. And so Kafka streams, or streams in general, are an unbounded ordered sequence of structured data records, and they are defined as key value pairs which are continuously updated. And when you work with Kafka streams, is when you create a stream in your service, it loads on startup of your service an entire Kafka topic into your stream. A Kafka topic is a logical category where the producing services are publishing events to, or the consuming services are subscribing to. For example, the profile bounded context has a profile topic, or the document service is relying on a profile topic, and the document-related services are accessing the document topic itself. So, and the stream itself is buffered into a state store, which is a lightweight embedded database, which is disk-based on your service. And so the topic itself is loaded into your stream and can be processed in the scope of your own service. And the thing is that the stream itself is not running on the broker. It's running in the same process as your microservice. So the streams make the data available wherever it's needed, and you don't have to do some remote calls which are to access, for example, the remote message broker. So in Kafka streams, Kafka itself comes with a streams API, where you can join, filter, group, and aggregate, and so on, streams themselves and process them in the scope of your service. And you can also process each message at a time by function-like operations like map, peek, transform, and so on. And when implementing stream processing, what you usually need is a stream itself, but also a database for enrichment. And the Kafka Stream API provides those functionality by abstracting streams and tables. So a stream itself is a change log of a table, capturing data records as state changes of the table itself. And the table is a snapshot of the latest value for each key in the stream. So they are very, very related to each other. They have a very strong connection, and you can transform a stream into a table, and a table into a stream. So in this stream table duality can be used very powerful in your microservices architecture as well. So we started using Kafka streams themselves by introducing materialized views. So in the previous example, when I was talking about documents displayed with this author-relevant data, in the Kafka streams example, we could do following. We can create a stream out of the document topic and load it into our service. And the author-relevant data itself can be loaded from the profile topic as a table for enrichment. And we can filter those, we can join those together. The stream, the document stream, and the profile table can be joined together and be stored as a result in a new state store, which is then accessible from the outside as an inbuilt materialized view. And this is then always updated, automatically updated whenever a new document has been added, for example, or when the profile data has been changed. So to compare those event-driven mechanisms is that with Kafka streams, you're eliminating the local copy. So you don't have to have this duplication effort, keeping a local copy in sync whenever, for example, a profile update has occurred. And so it pushes also the data to where it's needed. It pushes it to your service itself. So you don't have to, you can right away through your Streams API without remote calls. And this increases the pluggability. For example, when you introduce a new service, you can just plug it into the stream system itself, and without, for example, if you're not relying on your own data, can use the stream data right away. So in general, it lowers the barrier to entry for your new service itself. And looking now from hindsight, like what we have learned so far is starting small and focus on those that are easy to extract in the very, very first beginning is very helpful, because and also do one step at a time, one manageable step at a time, because if you put too much load on your shoulders in the very beginning, you are not gaining early results, and you're not really gaining confidence in handling microservices, and it's really frustrating if you can't, if you have very late experience with those and late results. And another one is to avoid feeding the monolith again, and to re-implement cross-cutting concerns per service level. Definitely handle your cross-cutting concerns very early on to avoid all these problems that we ran into. And when providing a centralized service, you avoid a distributed monolith by introducing a common contract that is stable for your downstream services. And to design your system to be easy to evolve, design it event-driven to achieve high decoupling and autonomy between your services. And also, I would definitely consider event stream as a shared source of truth a good try as well. And to come back to what I've mentioned in the beginning, be aware of your circumstances. So it's not, your transformation process is not running in isolation. And for example, if you have to match a very sharp timeline and do a transformation process in parallel, it causes a lot of frustration on both sides. And keep in mind that every journey is different, and our journey might be totally different than yours. Thank you for listening.
Thank you. So, first of all, don't forget to vote. That's the 20th time probably that has been said. There's a few questions asked through the app. If you have any questions now, I'll try to refresh. We have a few minutes left, so. Was one question is about the maturity of the company or the team that you embarked this journey with. So how experienced was the team, and how big was the team that you took along on this journey?
So we were, the one team was 13 people, and they are mostly senior in full stack experience and senior people in that field, but with very little DevOps practices in place. So that's also one thing that I can also address, is that especially when you're running on-prem, for example, is that it's also a shift towards a DevOps culture, and you have to consider this also, reflect this also in your team as well, in terms of, especially if we have a small team. So we had one big team and split it into 3 different ones. And but what's very important is also that you have, for example, a task force in the beginning handling monitoring, distributed logging, all these operational complexities, and that not every team itself is trying to solve it, but instead provide some mechanisms that every team can then reuse in the services.
Oh, we have a live question.
Susanne, thank you for the presentation. A question: building the shared state out of the event stream, it's a very nice idea altogether. But the startup time of the application or of the container depends a lot on the amount of the data which is existing in this event stream, and you have a few billions of events which needs to be loaded during the start time, and basically some of them actually have to be deleted because it's like updates and they are just redundant. What should be the suggestion there? Like, should you provide like full updates there inside of the event stream, or like what's your experience with that one?
So yeah, we are not Netflix that have to process 1 trillion messages a day. We have a few less. So one challenge is when you have to deal with a lot of data and you spin up a new service and you have to load this topic into a new service, is that you can run into a high load time, a long load time to load this data, this topic data in your service itself into the stream. So, and there are Kafka suggests three things. One is what you are doing mostly is to provide compacted topics. So we are don't have keeping not the data itself, but we keep the latest snapshot of each data record by its key, and this reduces the amount of data that to load your service.
All right, I had my finger on an interesting question, and then more questions came in, so I had to find it again. So you mentioned that there's, of course, overhead in microservices, a lot more than in a monolith. But now you have both a monolith and then microservices. So did the maintenance effort and the overhead increase as you were extracting microservices?
I'm sorry, what was the question?
Did the overhead increase, or did the effort of maintenance increase as you were extracting these microservices from the big monolith, making it harder for to extract the second one, because now you've got more maintenance to do?
Yeah, so especially what I mentioned before is so what so there's also, we increased the maintenance effort, especially because we had not every DevOps practice in place from the very beginning. And that's also one thing, that if you start with small services, at first you definitely have to take care of all your operational things, like definitely a separate CI/CD pipeline, but also monitoring on service level, and also log tracing and distributed logging and aggregate your logs. So if you don't have this in place and you are running your monoliths and your microservices in production, then it's causing a lot of headaches and a lot of effort to operate them. So also with services that you decompose, also establish the core DevOps practices as well.
Did you manage to kill the monolith?
No, not yet. And I guess we will still keep it as a tiny ball of mud. That's the goal.
A little piece of history.
So and then to address this one as with anti-corruption layers, just to keep. I guess it's not. So we are trying to focus on those services that where we are generating benefit out of it, and we are not decomposing on our monoliths in the sake of introducing new services. We are trying to focus on what service or what benefit we are retrieving out of it when we extract the service.
How frequent did you release to production with the monolith, and how is it now with the microservices?
Yeah, so the problem is we have a polyglot environment. So we have a cloud, and we also have on-prem, and unfortunately, on customer on-prem. So, and this is really, that's what I was saying. So our journey is totally different than probably others, because we have to face this complexity and we have to reduce it. So, and so the monolith itself was probably, I can't remember, but it was monthly wise. And so in the private cloud solution, we can deploy daily. So.
There's a interesting remark with a question from somebody in the audience who says, we have several hundred microservices, but there's still a core monolith. It's stable, so splitting it up never seems to get business priority. How would you or did you deal with that? Was that a problem in your case?
Yeah, it was a problem in our case, since the fact that we started with this very high-level bounded context of just drive and retrieving very late results was also we were not gaining confidence from the management either. So they came to us with, well, didn't you say that you would like to release changes early? But now it takes far longer, and it's a real problem with that one. And but the problem is that it takes longer in the very beginning, so you have to deal with it, that it's not it's slowing down your process instead of speeding it up.
What kind of scaled agile flavor, so somebody has an opinion here, did you use in order to manage your teams? Did you use SAFe or the Spotify model, or what? How did you organize your teams?
So we don't have tribes in that way. We have product line teams, and so as I mentioned before, that these teams are assigned to a set of collaboration apps that they take care of, from user interface down to data storage as well. And so what I was enforcing was that they can do their own autonomous decision to handle their own collaboration apps. So they are more product aligned, and can also choose their own agility methods. So for example, one team was running on Scrum, the other one was running on Kanban.
Somebody would like to know if you had any external help in this journey, or is it all you and the team figuring everything out?
That's a good question. So sometimes I was thinking, gosh, why didn't I ask for help? So, and the thing is, so we didn't have external help at that time. So, but I was attending a lot of conferences, and we were all digging into every book that we could read, every article that we can find at the moment, and also try to share this knowledge in our teams to discuss it, like which model works for us right now. But it's no external sources other than only.
And apparently, somebody in the room is seeking external help. They've noticed your ex-CTO as just social, and they're wondering if you're up for hire. That is not a question to ask through the app, because it's anonymous, and it's hard to get a working relationship anonymously. So if that was you, whoever it was afterwards.
They can
come up
approach me
from.
later. So it's, yeah, I'm right now in a transition, so, but I can ask this question later on, no problem.
Does anyone want to ask a question non-anonymously? It's scary, isn't it? It's okay, you'll survive. Most others did as well. Yes, here we go.
Did you consider any Kafka alternatives for storing and sending out the events?
I'm sorry, Kafka?
Alternatives.
To be honest, no, because we already introduced Kafka for notification and for events transfer purposes. And for example, we did not consider event store or something like that because we already had this one in place and we didn't want to introduce another component that we have to run and maintain. So that was just a simple reason that we did not consider that one.
All right, time's almost up. Thank you very much.
Thank you.
Thanks especially for leaving a little bit of time for questions. And please give her a warm hand of applause.
Thank you.